Stop everything you're doing right now, because what I'm about to tell you will completely shatter the way you think about reality, time, and the universe itself. Imagine holding something smaller than a single atom in the palm of your hand. Something so unimaginably tiny that no microscope ever built could even detect it. Now imagine that thing, in less than a trillionth of a second, exploding into something larger than an entire galaxy. Not slowly, not gradually, instantaneously, violently, incomprehensibly. That is not science fiction. That is what scientists believe actually happened to our universe approximately 13.8 billion years ago during a period called cosmic inflation. And the more you understand it, the more terrifying and beautiful it becomes. Here is where the controversy starts, and I need you to stay with me because most people get this completely wrong. The Big Bang was not an explosion in the way Hollywood has trained your brain to picture it. There was no massive fireball blasting outward into empty space. Why? Because there was no space. There was no time. There was nothing. And then, from that nothing, or more precisely from an extraordinarily hot and dense quantum state, everything began. But even before the Big Bang cooled enough for atoms to form, before stars existed, before light could even travel freely, the universe went through something so extreme that physicists genuinely struggle to describe it with human language. Inflation. Cosmic inflation. Between approximately 10 to the power of negative 36 seconds and 10 to the power of negative 32 seconds after the Big Bang, the universe expanded at a rate that makes the speed of light look like a bicycle. We are talking about space itself stretching, not matter moving through space. Space stretching. And according to the latest models supported by observations from the Planck satellite and the BICEP experiments, the universe during this period doubled in size at least 90 times, possibly more, in a window of time so short that no human unit of measurement makes it feel real. Let that sit for just a moment. Now here is the part that breaks people's brains. During inflation, the universe could expand faster than light because Einstein's laws of relativity govern how things move through space. But nothing in physics forbids space itself from expanding at any speed. This is not a loophole. This is fundamental to how the universe operates. And it means the observable universe today, stretching roughly 93 billion light-years across, could have originated from a region smaller than a proton. But why did inflation happen? This is where physicists get heated. The leading theory involves a hypothetical field called the inflaton field. Think of it like an invisible energy field that existed in an unstable, high-energy state, and like a ball balanced on the top of a hill, it was always going to roll down. As it rolled, it dumped enormous amounts of energy into space, driving that exponential expansion. When it finally settled into a lower energy state, inflation ended, and all that released energy gave birth to the hot, dense plasma of particles that we traditionally associate with the Big Bang. Some scientists even argue that what we call the Big Bang was actually the end of inflation, not the beginning. And that distinction matters enormously. Now here is where it gets even more unsettling. Inflation is not just a cosmological curiosity. It actually solves three deeply troubling problems in physics that kept scientists awake for decades. The first is called the horizon problem. Why does the universe look almost identical in every direction, even though regions so far apart could never have been in contact? Inflation solves this because those regions were once extremely close together. The second is the flatness problem. Why is the geometry of the universe so perfectly flat rather than curved? Inflation stretched any curvature out to imperceptible levels, just like how the surface of a balloon looks flat when you zoom into one tiny point. The third is the magnetic monopole problem. Early universe physics predicted strange particles called magnetic monopoles should be everywhere. We have never found one. Inflation diluted them to near non-existence. Three massive mysteries. One extraordinary event. That is why inflation went from a fringe idea proposed by physicist Alan Guth in 1980 to one of the most widely accepted frameworks in modern cosmology. But here is the thing most science communicators are too afraid to say out loud. We have not directly confirmed inflation yet. We are still searching for the smoking gun, which would be a specific pattern of ripples in the oldest light in the universe called primordial gravitational waves. The BICEP-2 experiment thought it found them in 2014. The announcement was global news. Then it was discovered the signal was contaminated by dust in our own galaxy. It was a devastating blow. But new experiments, including Bicep Array and the Simons Observatory, are hunting for this signal right now, with more precision than ever before. This is live science. This is happening. And when that confirmation comes, it will be one of the greatest moments in human intellectual history. Think about what you are. You are a being made of atoms forged in ancient stars, living on a rock orbiting a star, inside a galaxy, inside a universe that was once smaller than the period at the end of this sentence. And in a blink of time so fast it cannot be experienced, it became everything. The universe did not just begin. It erupted. It exploded into existence with such violence and precision that billions of years later, pieces of it developed the ability to look back and ask why. That piece right now is you. Follow this page right now because we are just getting started, and what comes next will challenge everything you think you know about time, space, and your own existence. Now tell me this in the comments. If the universe came from something smaller than an atom, what do you think existed before it?